Hello folks, we are back with another video of this exercise 7.2. It's a problem number 21 which we are supposed to do. It says that you are given the function tan squared 2x minus 3 which we have to integrate. Now one thing that we have to always keep in mind is that tan squared function we are not going to appreciate much because it doesn't have an integral. So every time that you're given a tan squared function, we are eager to convert it into sec squared, so that sec squared x, you know that the integral is tan x. So we will be eager to convert it into sec squared because we know only the integral of that. So tan squared we will not appreciate, we will not keep tan squared, we will just change it to sec squared and then work. So this is as good as writing integral of sec squared 2x minus 3 minus 1 and dx. So actually when we write it, it is going to be sec squared 2x minus 3 dx is one integral and the other integral is 3 dx. Now, sec squared 2x minus 3 looks really very complicated. So we'll have to make a small substitution here. Let u be 2x minus 3. Then in that case, when you take the derivative du over dx, it's going to be 2 derivative of x is 1 and 3 doesn't have a derivative. So in order to get the dx here, you can have du over 2 becoming dx. So when we convert the I, this integral will become sec squared u and dx becomes du over 2. That's it. So we are now ready to get our integral. Here the integral of sec squared function is going to be tan u, and this is going to be 3x because integral of dx is x, we know, plus c. And maybe a small refinement where we have to revert back the u, which is 2x minus 3. Tan 2x minus 3 minus 3x plus c is our answer. So that's all about it. The highlight point is that we have converted the tan squared first into sec squared and then we have worked with it. So let's take the 22nd problem. Is also very simple problem. Eventually when you reach till the last exercise, this will be like child's play for you, all these problems. So this is going to be sec squared 7 minus 4x dx. Now this is good because it's already in the form of sec squared, so we don't have to do much of conversions. But again, it's not sec squared x, but it's sec squared another function. So there we need a small substitution. Let's call u as 7 minus 4x. So your derivative du over dx is going to be 7 no derivative, and derivative of minus 4x is going to be minus 4 because x has got derivative 1. Since we want a dx here, it is going to be du over minus 4 to be dx. Like that, our I value is going to be sec squared u du over negative 4. So the negative 1 over 4 can go out and you have sec squared u du. Sec squared u, we know that the derivative is, the integral is tan u. So it's going to be minus 1 over 4 tan u, which you have to revert back, 7 minus 4x plus c. That's about that problem. Now we can go to the problem number 23, which says that I is sine inverse of x over root of 1 minus x squared dx. I have to confirm the question once again. Sine inverse of x over root of 1 minus x squared dx. Fine. It's very, very evident over here that it is the sine inverse function that you have to take the substitution, because that will take care of this root 1 minus x squared also. So let's see how. If we substitute u as sine inverse x, what happens? The derivative du over dx, we have all learned that it is 1 over root of 1 minus x squared. So when we shift the dx on the other side, you will get dx over root of 1 minus x squared. That entire thing can become du. So your I becomes sine inverse of u is already u, sine inverse of x is already u for you. So u times du, it's only that much. So u raised to 1. So x raised to n plus 1 over n plus 1. So u squared over 2 plus c, which is half times u squared for us is sine inverse of x the whole squared plus c. That's it. So that's for a problem where it says that you have the thing like this. We are observant about this root of 1 minus x squared, and that's how we get it done. Yeah, with more problems, I think we can meet in the next video where I think we have Yeah, it's not so simple, but I think it's workable. So let's, with those two problems, let's meet in the next video. Thank you.